All right, give this problem a shot. It's a little more difficult, and don't mind this graph. It's for explaining. I'm going to start solving it now. So we want the direction of a line passing through this point, and the line that we're looking for specifically is the maximum slope at that point. It's a little bit of a gnarly one. So what does it mean to have a maximum slope? First off, you have to understand you're dealing with a 3D graph or 2D variables. I like to think of like geography, like when they map out mountains and stuff, or in the weather when they show like high altitude is red and then low altitude is blue, something like that. And that's kind of what we're dealing with. So I drew this. It kind of shows like, you know, for certain xy values, you might have a bigger z or f of xy. And we want to see where you're going to have a maximum slope. So like right here, the slope would be kind of big. This is like a smaller slope. This is a pretty damn big slope right there in this direction. You see what I'm saying? Because you're going from a small xy point, or a small f of xy point, to a big f of xy point in a small region of space. Like if this was Google Maps or something like that, this might be a skyscraper, and this is like maybe a small building next to it, or a car, or just a street. You know what I mean? Something like that. Or it could be a mountain. That's kind of what you're looking for. Right? So we want to see where the max slope is. Now you're probably thinking, well, how the hell do we do that? I don't have a clue. I haven't ever seen this before. I'm here to help. I'm such a tool. It's a hard problem, but if you know that your gradient function always gives the direction of the max slope. That's just what the gradient function does. Okay, I'm not going to explain why, but the gradient function, the result, whatever you plug into the gradient function, will give you the direction of the maximum slope. Well, that's exactly what we want. We want the direction of the maximum slope at point 1, -2. So all we have to do is find the gradient function. Now again, I think this is given in the FE handbook, but this is also another one I think is good to remember. Gradient function is just the partial derivative. It's also easy to remember. It's the partial derivative of each component in that component's direction. So partial of x in the I hat direction, partial of y in the j hat direction, partial of z in the k hat direction. Okay. Now this problem is we only have two variables, and that's x and y, so we can get rid of this z. Don't have to worry about it. I'm going to rewrite the equation down here. All I'm doing is taking the equation above and rewriting it. Okay. So if we want this function, we need to find df dx, we need to find df dy, and we'll plug them in, and then that'll be it. So df dx is equal, the derivative of x would be 4x. The y you can treat as constant in this situation. Plus 3, that'll be a 0. Df dy is going to be equal to -2y minus 1. Now, we plug that into our gradient function. Actually, before I do that, let me factor. I just saw this. Factor out that -1 there, because why not? Makes it a little nicer to work with. Now we plug in our values into the gradient function. So 4x plus 3 in the I hat direction. We'll do minus 2y plus 1 in the j hat direction. All I did is took that negative one and made it a minus sign instead of now, like I said, we could plug in a values to this gradient function and it will give us the direction of the max slope. So all we need to do is plug in 1, negative 2. So f of 1, negative 2 is going to be equal to 4 times 1 plus 3 I hat minus 2, negative 2 plus 1 j hat. That'll be a 7 I hat, and that will be that's a negative 4 plus 1, so that's a negative 3 j hat. Now we have a little bit of redundancy because we have that negative, so we'll have 7 I hat plus 3 j hat. Yeah, looks good. So that would tell you that 7i plus 3j. To reiterate my point from earlier, let's go to that point 1, negative 2. So we're here. The vector direction, shoot, I just lost it. The vector direction with the maximum slope would look something like this. So if we were to draw our points, maybe we would have a little point here and a quite large point here. Whereas everywhere else on the XY coordinate plane, we wouldn't have as big a change in our result. I hope that helps. It's a bit of a tricky problem until you understand that the gradient function gives you exactly what this problem's looking for. So, yep.